Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we're going to talk about the wind, forces, balance, and imbalance. And as Bob Dylan once said, the answer is blowing in the wind. All right, let's go on ahead and take a look at this. We've talked about this before, where the pressure gradient force and the Coriolis force come into play, where the Coriolis force is due to the Earth's rotation. And so we have an area of low pressure, and the pressure gradient force is directed inward toward the area of low pressure from high pressure in all directions. And so that's what generates the wind. However, there is a problem with the Earth's curvature coming into play, and so that turns all of the winds 90 degrees to the right, and this is why we don't have air collapsing into the middle of the low, that we have a counterclockwise flow around areas of low pressure. And if we were to do the same thing with a high, you would see that it would end up being a clockwise flow. Okay, so let's take a look at this in more detail and what may actually mess up that balance. So we've got the balance between the Coriolis force to the right and the pressure gradient force to the left. Now, let's introduce, and by the way, this is called in meteorology the geostrophic wind. It's a balance between the pressure gradient force and the Coriolis force. However, what happens when we introduce friction? Well, for instance, there's always friction over either water or land, but it tends to be a little bit more over land, and friction slows things down, okay? So, if friction comes into play, then that slows the wind down, and the Coriolis force is proportional to the wind speed. Okay, so if the wind speed goes down, the Coriolis force has to go down, and now we've got an imbalance of forces where the pressure gradient force is dominating, and that tends to turn the wind a little bit more toward low pressure. Okay, so in this situation, when you look at a weather map, the winds don't usually blow exactly parallel to the isobars. They tend to cross the isobars toward lower pressure, on average at about maybe a 30-degree angle, okay? And so this is then called an ageostrophic wind because the winds are no longer in balance between the pressure gradient force and the Coriolis force. Friction has come along and messed that up, all right? Now, we also have something called the gradient wind, which is associated with curved flow, okay? Now, we're first going to talk about the flow being curved in a cyclonic manner. So the air is going around a low pressure area like this, okay? And so it's curved in what we call a cyclonic manner. And everywhere along that path, the pressure gradient force is to the left of the flow and the Coriolis force is to the right. But now, because the flow is curved, we have another force that is coming into play, and that's called the centrifugal force, and that tends to pull the air outward away from that curved flow. And you have probably sensed this when you're driving a car, that when you turn to the left, you feel yourself being pulled to the right, okay? It doesn't actually end up pulling you to the right, but there's a force there that's trying to do that, okay? So now you've got one force going to the left and you've got two forces going to the right, and we no longer have a balance, okay? So let's look at this in more detail. Here's our wind, pressure gradient to the left, Coriolis force to the right, and the centrifugal force is also to the right. And so now, in order for balance to be restored, the Coriolis force has to decrease so that it teams up with the centrifugal force to balance the pressure gradient force. Well, as the Coriolis force decreases, the wind slows down along with that because those two go together. And so the wind becomes what we call sub-geostrophic, okay? In other words, if you were to calculate how strong the geostrophic wind should be, then in actuality, it would be subgeostrophic in these areas because of the fact that the flow is curved. Now, we have the other situation, of course, where the wind is curved in what we call an anticyclonic manner around an area of high pressure, okay? So here's our wind, but remember, now we're going around a high as opposed to the other way around the low. Pressure gradient force to the left, Coriolis force to the right, but now the centrifugal force is teaming up with the pressure gradient force. And the Coriolis force is feeling quite intimidated by this whole thing. And so the Coriolis force has to then increase, okay, to balance the centrifugal force and the pressure gradient force. And the wind speed is proportional to the Coriolis force, right? So as the Coriolis force increases, the wind speeds up, and then it becomes what we call supergeostrophic. So as you have curve flow going in an anticyclonic manner and you were to calculate what the geostrophic wind should be, in reality it would end up being faster than that wind speed because of the fact that the flow is curved in an anticyclonic manner around that area of high pressure. Okay? So winds can do all sorts of different things, and there are all sorts of things that come into play. The pressure gradient force, which is high to low pressure, the Coriolis force, which is caused by the Earth's rotation, the effect of friction comes into play, and also centrifugal force comes into play when you have a curved flow. So all sorts of complicated things going on here. And I think we've also in the past talked about with jet streaks, where you have an area within the jet stream that's blowing faster than it is anywhere else, and when the air accelerates and moves into that jet stream, then it's out of balance and it has to either turn to the left or turn to the right in order to restore that balance. And so that's another example of how the atmosphere is constantly trying to adjust. And this really, in a sense, is what causes weather, is that the atmosphere is constantly trying to restore balance in so many different ways, and it never finishes the job. And because it never finishes the job, we keep having weather. And that's what keeps me employed. So I'm thankful for that. All right, that is bonus weather video number 1 for this week. Hope that made a little bit of sense. And we will be back with bonus weather video number 2 on Friday. And, of course, another daily weather update. We already have the one for today posted, but another one will be up late tomorrow afternoon. So we hope you'll join us for both of those. So happy Valentine's Day, and you all have a wonderful evening. We'll talk to you tomorrow.